So I got 50 mm. Okay, so this I got it as 40. This individual I got 50, 50, 50 and 50. Okay, and what about this? Regarding this, you have to go back to steel table. So there you will get EXX and CXX. See, so this value is EXX, this value is from here to here, from junction to the center of bolt is EXX, and from here it is CXX. Okay, if you want, I'll draw the sketch here. If you go to steel table, so this value, so this is CXX, EXX. I have to refer from steel table again. So I have got the value of EXX, that is 30.4. This has 59.6, 30.4 and 59.6. This is very important. Okay, while selecting the properties from steel table, you have to take care. Okay, then after that, I got, next we have to go for the analysis of member. The next step is the analysis of member. So analysis of member, again you have to check the strength of provided member in three categories, that is strain due to yielding of cross section, strain due to rupture and strain due to block shear. So we will check one by one. Okay, so first in analysis of member, first we have, that is strain due to yielding of gross section, strain due to yielding of gross section, which is nothing but given as TDG is equal to AG into Fy upon gamma m naught. TDG is nothing but AG into F upon gamma m naught. Okay, so it is again AG is, you have what, that is 2274, Fy is 250 upon gamma m naught is 1.1. So I got 516.8 kilonewton, which is more than 400 kilonewton. Hence, okay. Therefore, okay. So the strength of gross section is 516 and the force applied is 400 kilonewton. So therefore, it is okay. No problem. Now we will go to next, that is strain due to fracture at critical section. Strain due to fracture at critical section. Okay, so we know that, again the equation from steel table, it is, you have to find out TDN is equal to 0.9 ANC Fu upon gamma ml plus beta AGO Fy upon gamma m naught. So here the important is, first of all you have to find out what is the value of ANC, AGO and beta. Okay, so we will calculate one by one. So ANC is again area of connected leg. So connected leg is 90 minus, if I cut along the critical section like this, if I cut it like this, so one bolt hole, so 90 minus, it is again 90 minus 22 minus, it is 6 mm, 8 mm, sorry, 90 minus 8 by 2 into 8 into 2, you have to multiply. Why 2? Because there are two angles back to back. This is for 2 ISA, you have to multiply because of 2 ISA. Okay, for 2 ISA. Okay, so this you will get this area as 1024 mm square. And AGO is for outstanding leg, cross area, 60 minus 8 by 2 into 8 into 2. Again for 2 ISA, this is multiplied by 2 ISA. So I got 896 mm square. Okay, so it is 896 mm square. Okay, so after that Next value for beta. So for beta you required BS and LC. For beta you require BS and LC. So LC is nothing but length of connection from first bolt to last bolt. So 5 bolts means 4 pitch. So 4 into 50. So 200 mm. BS is W plus WI minus T. So I got W is 60. WI is 30.4 if you check, minus T is 8. So I got the value for BS is 82.4 mm. Okay, so if you want I'll show you. So here it is, this is W, okay, W plus WI minus T. So W is 60, WI is 30.4, so W plus WI minus T, so I got 82.4. okay. So by doing that, therefore the value of beta, I got the value of beta as 1.25. so you have to check that with my calculation. So I got value of beta as 1.25. okay. So later on, so therefore, so after subtracting all the values in TDN, okay, the value of TDN is got 556.83 kilonewton, which is more than again 400 kilonewton. So therefore, okay. So again it is the section what you have provided, it is again safe in rupture. Okay. So next move on to strain due to block shear. So the third criteria what you have to check, that is third is strength due to block shear. So again one by one, okay, for block shear I will not write the formula here. So we want to find out for TDB1 and TDB2. So for that we require the gross area AVG, AVN, ATG and ATN. AVG, AVN, ATG, ATN. Okay, the gross area AVG, AVN, ATG, ATN. So again AVG is what? So if you want I'll show you here. Okay, so this is angle section connected with 5 number of bolts like this. This connected with 1, 2, 3, 4, 5. Okay, so the failure will takes place. The failure will takes place. Okay, it has to start from the end of the angle. So the longitudinal path will be along the direction of force. So this is the direction of force. It will start. It will continue up to the last bolt. Okay, so that is 40 plus 5 times 50. So that is 40 plus 5 times, sorry, 40 plus 4 times, sorry, 4 times 50. 1, 2, 3, 4. Okay, 40 plus 4 times 50 into 8 into 2. Why again? This is 2 ISA. This is what 2 ISA. Okay. Then AVN. AVN is that area. So 40 plus 4 times 50 means 240 minus how many number of bolts? 1, 2, 3. How many number of bolts? 1, 2, 3, 4, 4.5. 4.5 minus 20 into 22 into 8 into 2. Okay. Then ATG. ATG again for the failure will takes place from center of last bolt to the here. So this part will be called as a block shear. So this is as a block. So this part and this part will get separated in block shear. Understood? So ATG again. So this is I think 59.6 into 8 into 2. Okay. Then here 59.6 minus half of the dia of hole into 8 and into 2. So by this I got the values. I will read out the values here. So I got this is as 3840 mm square, 2256 mm square. This is 953.6 mm square. This is 777.6 mm square. Okay, these are the values I got. Okay, so after getting those values and when you substitute back in the formula, so that is TDB1 is equal to TDB2 is equal to. So I got TDB1 as 773.41 kilonewton, and TDB2 as 601.22 kilonewton. Okay, both together I got. Then so therefore TDB is least of these two, so that is 601.22 kilonewton, which is again more than 400 kilonewton. So in all the categories, our section we have got safe, because the design strength of the member is more than the designed tensile strength of the section. Okay, so hence it is safe. Our section whatever provided, it is safe. Okay, so my request is you go back with the calculation, go back with the video, go through the video and solve the problems. Okay, and discuss with your friends regarding the queries, and if you get any doubt, you can contact me. Thank you.